This is the summary for lesson 9. Slopes don't have to be positive. And in the summary, the authors draw this line for you. It's the black line here, and they give you two slope triangles. And I'm going to compare what the authors drew with a line that is a reflection of the first line that they give you. So I'm going to draw a second line that's a reflection over the value of the y value of 25. That's this orange line right here. So if I take their line and reflect it over that orange line, I get this purple line. And so I want to go back to what we know and then compare that to what we've learned in this lesson. So this is a situation where the snow has fallen. It's 30 inches deep, and then it begins to melt at a rate of 1 inch per hour. And so if we go to what we know, if this is a positive slope, now this is not melting, this would be accumulating, this would be adding more snow at this same rate, 1 inch per hour. So if we go to what we know, the horizontal change is 5 units. So from 5 hours to 10 hours, that's a positive change of 5. And there's a 5-inch increase in the amount of snow. So you're going from 25 to 30. So the slope then is the vertical change, which is positive 5, divided by the horizontal change, which is also positive 5. Well, positive 5 divided by positive 5 equals positive 1. So this is a positive slope of 1. And if you, to figure out, so that's the right side of the equation, slope equals positive 1. So now we have to figure out the x's and the y's on the left. Well, what you do is you take the y value, and you have to get rid of this 25. So you're basically going to shift this triangle down to the horizontal axis by subtracting the 25. So it starts at 25, it ends at y, and so to figure out what that change is, it's y minus that 25. So this slides down, so it's y minus 25. And to figure out the change in the x value, you have to take where it starts at 5, and it ends at x. So it ends here at x. So that change is you have to subtract this 5. So now you're sliding the slope triangle over to here. And remember, the whole idea of this, when we used these slope triangles in the past, was to get this vertex to the origin right here, 0, 0. So this is x minus 5. So it's y minus 25 over x minus 5. And that equals a slope of positive 1. Now, I'm not going to go through all the algebra for you, but if you did that, you'd end up with an equation that says y is equal to 1x plus 20. And notice that the y-intercept is at positive 20. So this line has a slope of 1, and it goes through the y-axis at a positive 20. Now, if you compare that to a slope triangle that starts at the same point, but instead goes down 5 units. So this is the line that they give you in the beginning. So the horizontal change is the same, it's positive 5, but now it's going to go down 5 units, so negative 5 units. Well, a negative 5 divided by positive 5 is negative 1. So in this case, the slope is negative 1. Before it was positive 1. So now if we slide this slope triangle down, remember you have to subtract where you start. So this is going to be y prime minus 25. So we're sliding this slope triangle down to here. So that's y prime minus 25. And now we're going to slide it over by subtracting this 5 from the x value. So this is x prime minus this 5. So now this slides over to here. Slides over to here. So it's y prime minus 25 over x prime minus 5. So y prime minus 25, and then x prime minus 5. Slides it over to right here, and that equals negative 1. So now we have an equation of y equals negative 1x plus 30. So if you go through the algebra, you're going to end up with this equal to a positive 30. So notice that the y-intercept over here is positive 30. So y is equal to a negative 1x plus 30. So this has a negative slope, starts in the upper left, goes to the lower right, and this line has a positive slope, starts in the lower left and goes to the upper right. And the idea is to move this vertex from this point to this origin so that you can figure out the equations for both of these lines. Now, it doesn't make a difference. The authors like to start out with the vertical change and then put that over the horizontal change. I like to start out with the horizontal change because that's what we've always done. So it compares nicely to what we've done in the past, and then include the vertical change. So instead of going up positive 5 units, you're just going down 5 units. So that's a negative 5. But either way, you're going to end up with the same answer. So the horizontal change in both cases is positive 5. This is positive 5 right here. The change in the x value is positive 5. Change in the y value is negative 5 in both cases. Either start out with negative 5 or you end with negative 5. But still, that's the change in the vertical directions. That's that negative 5 right there. And so you factor out the 5s, you end up with negative 1 divided by positive 1. That equals negative 1. So in this case, you end up with the slope, both cases, you end up with a slope of negative 1. So the snow is melting at a rate of 1 inch per hour. So it's going down 1 inch per hour. So that's a negative slope. So the vertical intercept is 30, since the snow was 30 inches deep to begin with. Graphs with negative slope, the quantity is decreasing over time. So you notice that it's decreasing over time at a rate of 1 inch per hour. So that's a negative 1 slope. Now slopes can also have, lines can also have a slope of 0. So in this case, Elena won a contest at a carnival where she got $5 put on her fare card for taking free bus rides for a year. So her fare card has $5 on it. So what happens for the first few days? Actually, she doesn't use her fare card for the next year. So the first few days, what it shows is after 2 days, she still has $5 on the card. After 5 days, she still has $5 on the card. So how much has that fare changed on the card over those 3 days? Well, it's changed 0. So the change in x, or the number of days, so there's 3 days for the change in the x value along the x-axis, but the y, the value in the vertical direction, doesn't change at all. Doesn't increase, doesn't decrease. She hasn't put more money on the card, or she hasn't taken any rides to take money off of the card. So that's a change of 0. So 0 divided by 3 is 0. So the slope of this line is 0. It's not changing over time. So rate of change of 0 means that from one point to the next, the y values remain the same. They do not change. Now, I want to compare this just for a moment to what we've done in the past. So I'm going to make the horizontal change for all 5 of these points the same. It's 4 units. 1, 2, 3, 4. And I'm only going to change the vertical values, the vertical change. So this is a change of positive 2. So this would mean that she's adding money to the card at a rate of, looks like 50 cents per day. So 2 days adds $1, 2 more days adds another $1. So that's 50 cents per day. This is a change of 1 unit in the vertical direction, positive 1, over 4 units in the horizontal direction. So this is a change of 25 cents each day. So she's adding 25 cents each day. So 25 cents, 25 cents, 25 cents, and finally adds a total of $1 over 4 days. This is no change. Here she's using up money on the card, and this is using up 25 cents each day. So it's going down 1 unit, but the horizontal change is 4 units. So this is a negative 1/4. That's 25 cents each day that it's going down. And let's say the fare is doubled. So she's using 2 units going down. 2 units over 4 days. That's a change of 1/2, or 50 cents each day. So 50 cents, 50 cents, 50 cents, and 50 cents. So lower left to upper right, that's a positive slope. A straight horizontal line, that's 0 slope. and upper left to lower right, that's a negative slope. And so I like writing the equation this way, including the x value as the slope is 0 times whatever x value you're given. So however many days you're looking at, that's going to end up being 0, because x times 0, or whatever it is, times 0 is 0. And then you're going to add the $5 that are on the card. So you're always going to end up with y equals 5, regardless of the number of days. But let's say that x is 7 days. So if you use this equation, you know where to put that 7. It's 7 times 0. That's 0. And remember, you have to add the $5 that's already on the card. So how much money do you have on the card after 7 days? You still have that $5. Why do you still have that $5? Because you've used up 0 amount of money over those 7 days. You're not using anything. You're not using the card.